Millions of customers, including the fastest growing startups, the largest enterprises, and the leading government agencies, are using AWS. AWS is aiding them to lower their costs, become more agile, and innovate faster. Hello everyone, on behalf of Thinknyx Technologies, I would like to welcome you all for another exciting video. Today we are going to learn about the basics of AWS. Before we get started, let me introduce myself. I'm Deepthi, working as a technical specialist at Thinknyx. With more than 10 years of experience, I have delivered numerous trainings on cloud technologies. I'm also an AWS Solution Architect Associate certified. Let's take a look at the agenda for today. First, we are going to discuss on AWS fundamentals. This includes AWS regions, availability zones, and local zones. Next, we will take a look at some of the AWS services in terms of scope and accessibility. Also, we are going to have a look at some of the AWS services in terms of IaaS, PaaS, and SaaS service provider. At the end, we will take a look at the demo on the creation of a simple EC2 server. So without any further ado, let's quickly get started. Let us now understand what is AWS. AWS stands for Amazon Web Services. The leading cloud computing platform by Amazon was launched in the year 2006. AWS provides on-demand delivery of services through the internet with pay-as-you-go pricing. This is nothing but cloud computing. With cloud computing, we don't need to make any large upfront investments in hardware and spend a lot of time on heavy lifting of managing that hardware. Cloud providers like AWS will take care of it on behalf of us. If you're new to cloud computing, we would highly recommend you to watch our Cloud Fundamentals tutorial first. Click on the top right corner or check out our description box below to find the link for the same. AWS offers over 200 fully featured services providing scalable and cost-effective solutions. Let us now discuss some of the benefits of AWS. The first and the foremost is the security. AWS utilizes an end-to-end approach to secure and harden our infrastructure. It includes physical, operational, and software measures. Next is availability. AWS delivers the highest network availability of any cloud provider. Each region is fully isolated and comprised of multiple availability zones. Next is performance. AWS region offer low latency, low packet loss, and high overall network quality. Next is scalability. Customers used to over-provision to ensure that they had enough capacity to handle their business operations at the peak level of activity. With cloud, we can instantly scale up or scale down as per our business needs, and we can provision only the required amount of resources. This reduces the cost and improves our ability to meet the customer's demand. Next is flexibility. The AWS global infrastructure gives us the flexibility of choosing how and where we want to run our workloads. Say for example, if we would like to run our applications globally, then we can choose from any of the AWS regions and availability zones. Or if we would need to run our applications with millisecond latencies to mobile devices and end users, then we can choose AWS local zones or AWS wavelength. Or if we would like to run our applications on premise, then we can choose AWS outposts. Next is global footprint. AWS has the largest global infrastructure footprint of any provider, and this footprint is constantly increasing at a significant rate. Let us now talk about AWS global infrastructure. At the time of the recording, AWS spans 96 availability zones within 30 geographical regions all around the world. It has 25 local zones. So let us understand what are these regions, availability zones, and local zones are. Let us now start with AWS region. AWS has the concept of a region, which is a physical location around the world with clustered data centers. AWS opens new regions rapidly. AWS maintains multiple geographic regions, including region in North America, South America, Europe, China, Asia Pacific, South Africa, and the Middle East. Say for example, we have AWS region in Northern California in North America, the latest being in Hyderabad in Asia Pacific and London in Europe. AWS also have government cloud regions. These are not available for the general public and this is specific only to the US government. Let's now discuss AWS availability zones. An availability zone is one or more discrete data centers with redundant power, networking and connectivity in an AWS region. Here we have 3 availability zones within a region. All availability zones in an AWS region are interconnected with high bandwidth, low latency networking over fully redundant dedicated metro fiber, providing high throughput, low latency networking between the availability zones. Let us now talk about AWS local zones. Industries like online gaming or media and entertainment require single-digit millisecond latency. So if the AWS region isn't close enough, then these industries had no other option but to provision and manage their own infrastructure. But now AWS has provided the solution for the same, and that is local zones. AWS local zones are a new type of infrastructure deployment that places compute, storage, database and other select AWS services close to large population and industry centers. We can use AWS local zones to run various AWS services including EC2, VPC, EBS, etc. We can build and deploy applications close to end users to enable real-time gaming, live streaming, augmented and virtual reality, virtual workstations, and many more. We can enable local zones without any additional fees. We pay only for the services that we consume in the local zones. AWS local zones are all over the globe. For example, we have at Miami in US, Helsinki in Finland, and Bangkok in Thailand. Let's discuss some of the AWS services in terms of scope and accessibility. Our account determines the regions that are available to us. An AWS account provides multiple regions. To understand the scope and accessibility, let's have a look at the example here. Here we have 2 regions. One is Northern Virginia with the code US East 1 and the other is Northern California with the code US West 1. As we already know, each region has multiple isolated locations known as availability zones. Here we have 3 availability zones for each region. For example, for Northern Virginia, we have US East 1A, US East 1B and US East 1C. All AWS services are either global, regional or availability zone specific. They cannot be accessed outside. A service that is available across the AWS account is called as a global service. Global services are the services which can store and process the data globally. Let us understand some of the example of global services with the help of use cases. Suppose we want to restrict the access on who can start or terminate the server, then we can do so by using IAM. IAM stands for Identity and Access Management. With this, we can manage who or what can access the services and resources in AWS, and it is absolutely free to use. Next one. If a website needs a name or if we want to connect our browser to any website, then Route 53 does it for us. With Route 53, we can connect user requests to internet applications running on AWS or on-premise. Next one. Now, if we want to store a file on cloud and it should be highly available, then S3 fits the best for this. S3 is an object storage service which offers scalability, data availability, security, and performance. Next, we are going to talk about regional services. Regional services are those services which are available only in that particular region. Suppose if you have created a regional service in Northern Virginia, then you cannot access this service outside this region. Say for example, we cannot access this in Northern California. So now let's take a look at the examples again using some real use cases. If we want to detect unhealthy EC2 instance and route the traffic only to healthy EC2s, then ELB should be your choice. ELB automatically distributes incoming application traffic across multiple targets and virtual appliances in one or more availability zones. Next one. Suppose we want a serverless, fully elastic storage, then Amazon Elastic File System is the best suited. EFS automatically grows and shrinks as you add and remove files with no need of management or provisioning. Next one. If we want to launch a simple website or blog on AWS, then VPC is a must. It represents a logical network that is isolated from other resources in the AWS public cloud. Now let's talk about zonal services. Some services are accessed only within that particular availability zone. Suppose a zonal service is created in US East 1A, then it cannot be accessed anywhere else, not even in US East 1B or even in US East 1C. With the help of use cases, let us understand some of the zonal services. Suppose we want to host a game on AWS and we need to control to stop and start whenever we require, then EC2 is the answer for us. EC2 offers the broadest and deepest compute platform with over 500 instances. Next service. If we want to easily resize clusters for big data analytics engines such as Hadoop and Spark and freely detach and reattach volumes, then Amazon Elastic Block Storage is the best for us. EBS is a scalable, high-performance block storage service designed for EC2. Next one. If we launch AWS resources such as EC2 instance into a specific subnet, by launching EC2 in a specific availability zones, we can protect our applications from the failure of a single zone. Let us now talk about AWS services in terms of IaaS, PaaS and SaaS service provider. AWS provides services in terms of all service models, that is IaaS, PaaS and SaaS offerings. IaaS or infrastructure as a service is a model where cloud delivers infrastructure like compute, storage and network resources on a pay-as-you-go basis over the internet. We are responsible for deploying, maintaining and supporting our applications, while the IaaS provider is responsible for maintaining the physical infrastructure. Some of the IaaS services that AWS provides are EC2, ELB, VPC and EBS. We have already discussed these services in the previous slide. So let's go to PaaS. PaaS or a platform as a service is a model where cloud provides hardware and software infrastructure that we can use to develop and maintain the applications. Some of the PaaS services that AWS provides are RDS. Amazon's relational database service is a collection of managed services that makes it simple to set up, operate and scale databases in the cloud. Next is AWS Lambda. With AWS Lambda, we can run code without provisioning or managing the infrastructure. We can even save cost by paying only for the compute time, that too in milliseconds. Next is Elasticache. Amazon's Elasticache is a fully managed in-memory caching service supporting flexible real-time use cases. Next is DynamoDB. Amazon's DynamoDB is a fully managed, serverless, key-value NoSQL database designed to run high-performance applications at any scale. Next is Elastic Beanstalk. Using Elastic Beanstalk, we can deploy and scale our web applications. Let's move into SaaS. SaaS or software as a service provides the entire software application over the internet. Example for AWS SaaS services are SNS. Simple Notification Service is a fully managed service to deliver application to application notification and to distribute application to person notification with SMS texts, push notifications and email. Next is SQS. Amazon's simple queue service let us send, store and receive messages between software components at any volume without losing messages or requiring other services to be available. Next is App Flow. With Amazon App Flow, we can automate bidirectional data flows between SaaS applications and AWS services in just a few clicks. Before we jump into the demo of EC2 creation, let us understand what is EC2. EC2 stands for Elastic Compute Cloud. With EC2, we can rent virtual machines. These are called as EC2 instances. Based on our requirement, we can choose various types of instances with differing CPU, memory, speed and storage. With EC2, there is no long-term commitments. We can pay only by the hour or even by the second depending on the instance type. Also, it is important to understand what is AMI. AMI stands for Amazon Machine Image. An AMI is a template. It contains software configurations that are required to launch our EC2 instance. The configurations can be operating system, application server or applications. Say for example, we can choose operating systems like Mac OS, Ubuntu, Windows, etc. We have multiple options to select an AMI. Either we can select our own AMI or choose AMI provided by the AWS Marketplace, which are verified by AWS, or we can choose from the community AMIs, but these are not verified by AWS. Let us also understand what are security groups. Security groups are the fundamentals of network security in AWS. They act as virtual firewall. Security groups control the inbound and outbound traffic of EC2 instances. Whenever we launch an instance, we can specify one or more security groups. If we don't specify a security group, then EC2 uses the default security group. Inbound rules control the incoming traffic to our instance, and the outbound rules control the outgoing traffic from our instance. When we will have a look at the demo, then we will connect to the Linux machine using SSH. Let us now discuss on EC2 key pair. An EC2 key pair consists of a public key and a private key. They are the credentials for connecting to the EC2 instance. The public key will be stored on the EC2 instance while we will be storing the private key. So you can relate this to lock and key. Public key is like a lock and you can open it only through the key, which is the private key. Also, we have to secure our private key as EC2 do not maintain a copy of this. So there is no way to recover a private key if we lose it. We will now be creating a new EC2 instance running on Ubuntu. For those who are new to AWS Cloud, you need to first create a free tier account. To do so, go to aws.amazon.com and set up your account. Please note that you will have to provide a valid email ID and credit or debit card details for the account activation. Post that, go to console.aws.amazon.com and provide the credentials. Log in as a root user, give your email ID. Click on next, provide the security check and then the password, and this will take you to the AWS console. And your AWS console might look something like this. On the top right side, we can choose the AWS region. These are the AWS region which are enabled for me, and these 9 regions are not enabled for my account. As we have already learned earlier, AWS region are the actual geographical locations for AWS data centers. Each region contains 2 or more availability zones, which are the physical data centers within the specific AWS region. I'm selecting here as Northern Virginia. You can choose any other region of your choice, but I would suggest you to use Northern Virginia for this demo as AMIs might vary as per the region. Now choose services, choose compute, click on EC2. Alternatively, you can use the search bar and type EC2 over here. Before we jump into launching and connecting to the EC2 instance, we will now create key pair and the security group. As discussed earlier, the key pair are the credentials for connecting to the EC2 instance. To create the key pair, navigate to Network and Security, click on Key Pairs, click on Create Key Pair. Now give a valid name here. I'm going to give here as Thinknyx Key Pair. The name can include up to 255 ASCII characters, but it cannot include leading or trailing spaces. Next, coming to key pair type, either we can choose RSA or ED25519. Note that ED25519 keys are not supported for Windows instance. Next, coming to private key file format. Now we need to choose in what format we need to save the private key. To save the private key in a format that can be used with OpenSSH, then choose PEM. If you need to save the private key in a format that can be used with PuTTY, then choose PPK. For this demo, we will be using PuTTY, so I will download here as PPK. Now I'm going to click on Create Key Pair. This is going to download my private key. As mentioned earlier, we have to keep this very safe as AWS doesn't maintain a copy of this. Now remember, the region is Northern Virginia. Now let's create the security group. Security groups control the inbound and outbound traffic of EC2 instance. They act as firewall for the associated instance. Now we need to add rules that enable us to connect to the EC2 instance from our IP address using SSH. So again, we are going to navigate to Network and Security, click on Security Groups. Now click on Create Security Group. One important point is that the security groups are specific to a region. So we should select the same region in which we have created the key pair. Now I'm going to give a valid name here and add a description, and then I'm going to provide the VPC and keep this as default. Now coming to the inbound rules. Inbound rules control the incoming traffic to our instance. Let's create rule to allow specific traffic to reach our instance. Click on Add Rule. Click on, say for example, HTTP. In the source, let's choose Anywhere. Similarly, I can add another rule. This time let's choose HTTPS and click the source as Anywhere. Like this, we can add multiple rules. Now for this demo, I do not need HTTP or HTTPS, so I'm going to click on Delete. We need SSH, so I'm going to select the type as SSH over here. And here in the source, I'm going to select my IP. My IP will automatically add the IP address of my local computer. If your company or your router allocates addresses from a range, then you can specify that entire range over here. For security reasons, do not choose Anywhere for source with a rule for SSH. This would allow access to your instance from all the IP address on the internet. Next, we will go to outbound rules. We will keep the default rule. That means we are allowing all the outbound traffic. Next, we are going to hit on Create Security Group. Let's now launch the EC2 instance. To do so, click on Instances, go to Instances and click on Instances. Either you can launch instance here or from here. Now give a descriptive name. Now we have to choose the AMI or the Amazon machine image. We can choose either from here. I'm going to choose Ubuntu for this demo. You can also click on Browse More AMIs and select your own AMIs or from the marketplace and the community. Now coming to the instance type, I'm going to keep this as default T2 micro. You can choose any other instance type as well, but make sure it is free tier eligible. Next, we'll go to key pair. we have already created the key pair. So I'm going to choose Thinknyx key pair over here. Coming to network security, either you can create the security group over here, and this would go by the name Launch Wizard 1, or you can select the existing security group. As we have already created the security group, I'm going to click on this and choose the security group which I have created. Next, I'm going to keep the storage as it is. I'm going to launch only one instance. So I'm going to keep this as 1, and I'm going to click here as launch instance. This would give me the instance ID. Let's click on the instance ID over here. This would give me the details of the EC2. So let's discuss some of them. Say for example, the name, the EC2 name which I gave was Thinknyx EC2, and this is the unique ID of my instance, and the instance state is pending, and in just few moments it will be in a running state. And then coming to instance type, remember we had chosen T2 micro over here. Now if you see that the instance state has now changed to running state. Now if you could scroll, we could see that availability zone is US East 1A. So the region what we have chosen is Northern Virginia, and it has the code US East 1. As we have already discussed, EC2 is a zonal specific service. So it has taken the zonal availability zone US East 1A, and here goes the public IP DNS and the public IP address. The public IP address for me is this. We have to remember that this IP address, this public IP address, is a non-persistent public IP address. What do I mean by that is that whenever I stop the instance and start the instance later, then this IP address changes. So we will have to keep a note of this IP address all the time. So we can also use persistent IP, but this service is chargeable in AWS. Now let's move on. Coming to the security group name, Thinknyx security group is the group security group which we had chosen, and the key name was Thinknyx key pair, and this is our launch time. You can also scroll down to see the same details over here. Say for example, we have public IP address, the private IP address. One important thing to be noted about the private IP address is that these are the IP address that's not reachable over the internet. We can use private IP address for communication between instances in the same VPC. You can also click on security. This will give you the details on security group and its respective inbound and outbound rules. Coming to network, we have private and public IP address, VPC, subnet, availability zones. All those details are there here. This is storage is going to give the details about the storage. And then we can check the status. We can monitor our instance, and any tags which are associated will be displayed over here. Now that our EC2 is up and running, let's now connect to our Linux instance. To do so, we will have to go to PuTTY. We need to provide the host name. The host name goes by this particular format: instance username @ instance public IP address. Now to find the instance username, you can go to official website, and depending on the AMI, the username changes. We are using Ubuntu as the AMI, and the username for Ubuntu is Ubuntu itself. So I'm going to copy this Ubuntu, and next is the instance public IP address. To do so, we will have to go to details. This is the public IP address which we discussed. Copy this, and we are going to paste this over here. Now make sure that the port is 22 and the connection type is SSH. Now expand connection, expand SSH, click on auth, and we need to now browse the private key which we have downloaded. So this is the private key. Hit on open, click on open. This will connect to our EC2 instance. So click on accept. So note that the username is Ubuntu, and this is authenticated against the public key Thinknyx key pair. And I can give here as, say for example, who am I? This is going to give the username for me. I can also check the connectivity. Say for example, I can give here as ping www.google.com and we got the response from the Google. Note that this is 172.31.82.18 is nothing but our private IP address. So this is how we can connect and connect to our EC2 instance. Now we can click on instance state and we can choose either to reboot the instance or stop the instance. When you're stopping and starting the instance, make sure to check your public IP address. And you can, if you do not want the EC2 server again, then you can click on terminate instance. For this particular demo, I will not be using this instance again. So I will click on terminate instance, click on terminate. And this is going to terminate my instance in just few moments. So that's it about the demo today. With this, we have come to the end of the session. Let's see the highlights of the topics which we discussed. First, we discussed what is AWS and some of the features of AWS. Next, we understood what are regions, availability zones, and local zones are. Post that, we understood AWS services with respect to its scope and accessibility. Later, we discussed AWS as IaaS, PaaS, and SaaS service provider. And at the end, we had a small demo on creation of a simple EC2 server. Thank you for watching our tutorial. We really hope you liked our video. Please do like and subscribe and click on the link below to know more about Thinknyx. Do let us know what topic you're interested to know next in our comment section below. Thank you, Abhiyanto. We shall see you soon in our next video. Stay tuned for more updates from us.